So excited to be here. My name is Vlad, also known as Frolov, and oh, hold on, we are moving on. Yeah, and I'm working on building the dev tools for you, developers building on NEAR. So hopefully we will have a lot of insights today that some of you may not have learned before, but I hope every single developer on NEAR should know. So we will have it all done in 20 minutes. I'm with NEAR for over 4 years, and I love NEAR, love Rust, love open source. I'm also a co-founder. Yay! Also co-founder of the NEAR DevHub, and this is our community-driven initiative, and we want developers to feel home, feel excited, and feel that there is a space for them to innovate, to share just the best tech and their excitement among like-minded people. I'm also number 13 on the race of sloths. Check out what it actually means on the internet. Not number 1, but I'm getting slowly there, you know. I'm also actively helping our community in dev chats, so I know your pains, I know the common pitfalls, and I want you to not follow the steps any longer. You want to be productive day 1, minute 1. Today I want to say that NEAR is not crypto. NEAR is not web. NEAR is not Web3. The singularity is nearer. So that's where it all started, right? AI. What it all means. Will we talk about AI? No, NEAR protocol is the blockchain, and that is the tag that powers the NEAR AI. And today, and my expertise is on that side of things. And we had a lot of other talks covering all other parts, so I will not repeat myself on other talks. So today, we will briefly start immediately from the landing page of dev.near.org, which gets you up to speed in no time. One screen, like one pager, you understand it all. You can get started immediately. JavaScript, Rust, there are also examples for Solidity. You can build in Solidity for NEAR, thanks to Aurora. We are also exploring different paths with other languages like Zig, Python, Swift. We'll see how that plays. So check out to dev.near.org if you just started, but we'll run through it and learn what NEAR can offer, what we can do there. And today we'll talk about the best practices. And I want every single developer on NEAR to learn just 4 host functions before we dive in. So those are storage read, storage write, value return, and input. With those 4 host functions, you can build these simple contracts, and that will build and help you to develop the foundation understanding of what's the source of truth, what do you actually store in the contract. This is a minimum contract in JavaScript with just simple get greeting, set greeting methods available from your contract, which interact using the low-level API, the host functions of the blockchain exposed. You don't write the code this way usually. You usually want to use higher-level API, and we will talk about it in a bit. But I encourage you to learn more about the available host functions and what the blockchain offers to you in the environment you execute your programs. One of the main biggest security pitfall that people I see fall often into is the difference between predecessor account ID versus signer account ID. So predecessor account is the account that called the contract that we are implementing, and signer account ID is who initiated the transaction. Transaction could be initiated by one person, then cross contracts could have been in the chain, and then some contract called our contract, and we need to distinguish it especially if you want to check who was the owner, who was the initiator of the action, and we do not pass that ownership from the who signed the transaction. We want to actually get it from the who called us, because if you skip this step, you can suddenly allow some link drop contract withdraw USDT tokens of a user because they checked for signer account ID as an owner of the token versus predecessor. Second, you have to use the latest DevTools. The NEAR CLI, RES, and Cargo NEAR are there. It's admired in the NEAR community. You have to try it. Even outside of NEAR community, I talked to Rust Conf people. They just enjoy the way we construct the complex commands of CLI. So you have to check it out and play with it. It's just so much joy working with those. So this is Cargo NEAR experience. You do Cargo NEAR new, and you immediately have your full setup with CI/CD, with tests, and basic example ready for you if you are building in Rust. You can use Cargo, Cargo NEAR, create NEAR app to create your JavaScript contract, which has pretty much similar experience. You type one command, npx, create NEAR app, and select that you want to have a JS contract, and boom, you are also all set. So you have to use that to be on the safe side. And also, it's very productive to do so. Obviously, well, it could be hard, but especially for contracts, you want to use tests. Use tests, write tests to speed up your development flow. With tests, you can immediately check all the conditions and avoid repetitive work. Scripting it outside of your testing environment through CLI or other tools is not productive. And NEAR workspaces, JS and RES, are the frameworks that help you to achieve this. So this is the minimum, or not minimum, but the pre-extensive test, actually, which tests the state migration. So whenever you upgrade your contract, the state, the data of the contract remains to be there. And you want to have a test that takes the contract of the current version from the chain, from mainnet in this case, initiates it from that point, adds some dummy data. You can also pick some snapshot of the data from your real smart contract on mainnet as well. That could be also an option. And then you try to upgrade it in a test. So the test would try to upgrade your contract and then try to execute and check that it actually is still operational. So this is a very good example. And actually, I will refer to many examples that we built as part of DevHub development. So for DevHub portal, we do have a contract. We do have boss components. So we do experience the pains of all the developers on a daily basis, and we try to solve them, and we provide these best practices. And I often refer to pieces of code from our repos. CI/CD is also pretty standard and fun, and also once you script it once, it's so much joy to work with the project because you don't need to worry about, oh, is it actually a working change or not? You just have a test for it, and CI will take care of checking that it compiles, the state migration will not fail, and many other aspects of it. And then you can also script even like deployment. For example, for DevHub, on every push to main, we deploy the contract with CI/CD, and we do this thanks to the tests, we can do that safely, and we are pretty confident that we will arrive to the working version of the contract. Once you're ready, you should use and consider using strict types rather than JavaScript dynamic types. But I encourage you to explore the space as fast as possible with the tools that are most productive to you. So if you are more productive with JavaScript, go with NEAR SDK JS. It is feature complete, it's nice. Obviously, it's not as performant as Rust SDK, but it's like even in Web2 world, it's obvious to anyone that JavaScript apps versus Rust apps will have a performance difference. But performance of execution is not all you need. Sometimes the most valuable metric is actually time to market. So in that case, pick the tools that are the most productive to you. But when you are evolving and you want to be more sure in the security of your application, consider using strict types, define dedicated types, like, for example, on this slide, NEAR token is a simple wrapper around U128, so just integer type. But it only allows you to sum only like NEAR tokens. You cannot sum just random numbers. You cannot multiply it by a random number. So it's very nice to have such wrappers, abstractions for you to have a safeguards. And Rust is a very good language to do so. In TypeScript, there are more challenges. I wouldn't say that the ecosystem in TypeScript is that heavy on leveraging custom types, but still, like, it's up to you to define those. Also, worth mentioning the difference between various approaches to store collections of data, like dictionaries, maps, lists, and sets. So there is a standard, so in case of Rust, for example, JavaScript is actually the same. There are built-in collections, hash map, hash set, and vector or list, right? And you can use those. You can use those collections and just serialize them and put into the storage as JSON, as Borch, in any way. You put it and then you will be able to read it from there. But you need to be aware of the fact that you cannot put like millions of records under a single key there. So you need to have a solution to actually be able to store more elements. And if it's up to 100 elements, we have a benchmark, then it's actually totally fine to just serialize it as a like standard collections into single key. The problem is you need to make sure that your collection is either bounded, like say, so you know that it cannot hold more, like for example, 10 elements anyway, then it's a perfect example. If your collection, like NFT, for example, a collection could have millions of NFTs, then you should consider using the SDK provided types that just makes it easy to manipulate. Under the hood, it still uses storage read and storage write, but it's just a nice wrapper, so you don't need to worry about it. And what it does, it stores each individual element item of the collection as individual low-level, NEAR-provided local storage database element. For security aspects, I strongly recommend we all commit to building reproducible contracts going forward. It's been a journey for NEAR for a long time to not be able to ensure that the contract that you see on chain is matching the source code that you see on GitHub. Even if, as a developer, I say that, yeah, this is the repo, this is the source code, you had no way to prove it unless you had like a clear instructions in your repo how to actually reproduce it or where to see it. Now we have cargo NEAR build command that does it automatically for you. So it actually provides you a Docker environment that is frozen with all the like environment set up for the future to be able to just recompile the same source code in that environment and receive exactly the same byte WASM file as an output. And then you can confirm locally that it is the same contract. And this is how you verify that the contract matches the source code. This is the way how you see it on the CLI. If you go to and call contract source metadata, function on the contract, you will see how we arrived to this whole contract, including the link to the specific commit of the source code and all that information needed for reproducible builds. And we're all humans, so I would prefer some UI, and I'm very happy that NEAR Blocks team is very supportive of all such initiatives for developers. So they actually integrated this piece of tech already, and they load the code for you to inspect right from their UI. So this is like a collaboration of several teams, SourceCan, DevHub, and NEAR Blocks to arrive to this whole experience. So it's amazing and very useful for all of us. And I encourage you very strongly to resolve all the warnings that your compiler and Clippy linters are actually providing you. So this is an article from last year from Aurora team, and how they had to pay this amount to the security researcher who found the bug that was highlighted there by the linter all the time, facing like every compilation was just screaming at them, fix it, but they had to fix it for a little bit of money after all. And I also encourage you to never stop learning. There are a lot of useful sources and examples that you can take inspiration from and learn. These are just 4 that I often refer people to. They are not, by no means, the only available in NEAR ecosystem, but that's where you can find techniques like factories, CI/CD setup, use of latest tooling, and all that stuff. Web 4, you have to be ready. You have to be ready for this new era. It's actually been live for how many? Probably 3 years now, but it's not very widely known in NEAR ecosystem, I still believe. It's a very simple idea of a small gateway that sits and listens for HTTP traffic and turns those HTTP GET requests into a GET function call, web4 GET function call to your contract. So for example, devhub.near.page is a website that is served by the small gateway, but actually powered by the blockchain contract. So this is just a very good example of what NEAR technology allows us to build. If you are still new and lost a bit in my talk, I encourage you to start with dev.near.org website, find all the resources, connect with the communities, and get support in the various dev chats, and subscribe for the newsletter to be up to date. We have a weekly collection of all the latest, greatest dev news in NEAR ecosystem. If you want to help open source and play a bit with like NEAR future, how we will see the open source and NEAR interacting, Race Loss is a great project to play around. You can gamify your day-to-day boring development with contributions, and create a PR, mention the Race of Sloth user on GitHub, and you will be greeted by the bot, and you will get scores on the way. You don't need to leave GitHub at all. That's all integrated into the GitHub, and this is under the hood. It's powered by NEAR, and this is the example of apps that I believe should be out there more and more. Not trying to build just Web3 or like blockchain app, but actually leverage blockchain to solve specific problems that blockchain can help you solving, and use all the available Web2 tooling for everything else to be productive And that's it. So be updated. Go check out DevHub, social media, and happy to have you talking to me in any corner of this Redacted event. And have a great event.